In this video, we will be completing our Unit 1 notes with Part 8, which is on metric conversions. The International Unit System is called System International de Units, which is abbreviated SI. In this table, we can see a bunch of the units that we will be using within our course. For length, the standard unit is meter, which has a symbol of M. Mass, our standard unit, is kilogram, with a unit symbol of kg. Time is measured in seconds, with an abbreviation of S. Temperature, we often use Celsius within our course, but the standard unit for temperature is Kelvin, which is symbolized by a capital K. Quantity is mole, which is abbreviated MOL. Electric current is ampere, which is abbreviated with an capital A, and luminous intensity is candela, which is abbreviated by CD. Now, we won't really be doing too much with ampere and candela in chemistry, but you'll see those more in physics. The rest we are going to be using a lot in our course. From our standard units, we can then make derived units. So these are units that include multiple units. So for example, area. An area could be measured in square meters, or meters squared. Volume is measured in cubic meters, so we have m to the third power. Density. Our standard unit here is kilogram per cubic meter, or kg per meter cubed. In our class, we typically use grams per centimeter cubed. So that's the same thing. For energy, we have joules, which is actually made up of kilograms times meters squared times the inverse of s to the negative second power, s meaning seconds. Pressure is in pascals, which is PA, which involves kilograms, meters, and seconds. And then power is in watts, which is kilograms meters squared over s to the negative third. And frequency is in hertz. It's abbreviated Hz, but it can also be abbreviated as inverse seconds, or s to the negative first power. Now, why are we going to be doing these conversions? When taking a measurement, you typically use a base unit shown in the SI units table. However, sometimes this can become inconvenient if the number is either very large or very small. So for example, each day when I drive to school, I drive approximately 24,500 meters. For such measurements, you can add a prefix to the base unit to keep the number relatively small. So after performing a conversion, you could say that I drive 24.5 kilometers each day. Dimensional analysis is a systematic approach to problem solving that uses conversion factors to convert from one unit to another. A conversion factor is a ratio of equivalent values which have different units. So this is a process that we will be using in order to do our metric conversions. In our example here, what is the conversion factor between dollars and quarters? Now everybody should know that there are 4 quarters within a dollar. If we are going to set this up as a conversion factor, you could say that you have 4 quarters over dollar or $1 over 4 quarters. Depending on what unit you're starting with, you might use either of these two potential conversion factors. In dimensional analysis, the units are going to need to cancel. Example 2. How many quarters are in $5? For our answer, you must choose between two possible conversion factors. So we know that we're starting with $5. Since I'm starting with $5 and I want dollars to cancel, that means dollars must be on the bottom of my conversion factor, and whatever I'm looking for, in this case quarters, must be on the top. So I'm going to use the 4 quarters over $1 variation as opposed to the $1 over 4 quarters variation. This one would not work. From here, our dollars are going to cancel out. We're left with quarters, which is the unit we wanted, and then we just do the math. So 5 times 4, which is 20. All right, before we get to our metric conversions, we're going to go through a couple of checkpoint questions using actual currency. So a Shroot buck is worth 0.0001 US dollars. How many Shroot bucks would Jim Halpert need to earn or photocopy in order to buy himself a $5 footlong tuna sub before tax? Now, the way that you would set this up, we know that we're going to need $5. So we're going to start there. So $5. We're going to set up a conversion factor. We know that dollars is going to have to be on the bottom. So we're going to use the 0.0001 dollars. We know that we're trying to get to Shroot bucks, and this many dollars is equal to 1 Shroot buck, which I'll abbreviate as SB. Our dollars are canceling here. We're ending up with Shroot bucks, which is what we want. So from here, we just have to multiply and divide across. So we have 5 times 1, and then divided by 0.0001. When we multiply across, we end up with 50,000 Shroot bucks. All right, for our next checkpoint question. 1,000 Shroot bucks can be exchanged for an extra 5 minutes of lunch break. How many Shroot bucks would Stanley Hudson need in order to take a 60-minute long nap? So this time we are going to be starting with the 60 minutes. I know that I need to cancel out minutes in order to determine how many Shroot bucks we're going to need. So now I need an equivalency to plug in here, the two numbers. We know that 1,000 Shroot bucks can give us an extra 5 minutes. So that's our equivalency. So we're going to multiply and divide across. So we have 60 times 1,000 divided by 5. So that's going to be 12,000. So you need 12,000 Shroot bucks in order to take an hour-long nap. All right, so now what this has all been building to is metric conversions. In order to do a metric conversion, you're going to need to know the equivalency, and you are not going to have to memorize these equivalencies for my class. So when you eventually take an assessment, you will be given a copy of this chart. Many of these prefixes you might know, such as kilo, like what you would use for a kilometer, or maybe centi, like centimeter, milli for millimeter. You might have heard of nanotechnology or the nanoscale, which is the scale of atoms. But there might be some others that you are not familiar with, most likely prefixes like hecto or tera. So what you would do is look back to this chart in order to see what the conversion factor is. The two most important columns here for what we're going to be doing is the symbol and the conversion factor. For our conversions, you're going to be keeping them in scientific notation. So you're going to need to reference this column right here. The dashed line that you see here is essentially where you're switching between things that are larger than 1 and things that are smaller than 1. So we'll come back to this a little bit later. Our rules for metric conversions. Units from the given quantity must go in the bottom of the conversion factor. So that's the exact same process that we were just practicing with the Shroot bucks. The larger unit will always be the 1 in the conversion factor. The smaller unit will get the number that is under the conversion in our table. That part's a little different from what we were doing before. If rule 2 is followed, the exponent within the conversion factor will never be negative, even if it is negative in the table. So we're going to be ignoring the sign of the exponent. That's very important. If at the end of this process, you have an exponent at the bottom of your conversion factor, you're going to bring it back up to the top, and then you're going to flip the sign of the exponent. At that point, you can have a negative exponent. These rules may seem a little confusing at first, but they should start to make some more sense once you see some examples. So let's look at a couple of examples of one-step conversions. When one of the measurements has a prefix and the other does not, you will perform a one-step conversion. And you can leave your answers in scientific notation. So let's say that we are starting with 5 millimeters, and I want to know how many meters that is. I would put the unit of millimeters on the bottom, and meters on top. Between a meter and a millimeter is larger. If you weren't sure about that, you could look at your metric conversion chart, and the part without the prefix meter, that's where your little dashed line was. And that dashed line is above the milli prefix. So this is bigger. The larger unit gets the 1, and whatever the smaller unit is gets the number from the conversion factor, which is 10 to the third. Now in your chart, it's going to be 10 to the negative third. We're going to ignore that part. Now the reason why we're ignoring that is based on the way that we're looking at this. We're saying that if we have one of these really big meters, we have 10 to the third or 1,000 of the smaller millimeters. Another way of thinking about this is 1 millimeter is equal to 10 to the negative third meters. And that's the reason why you have that negative sign in your conversion factor on that chart. But based on the way that we're going to be writing this out with the larger unit always being a 1, we're going to just ignore the sign. All right, so from here, we're going to multiply and divide across. At this point, since 10 to the third is in the denominator, we can bring that back up to the top by flipping the sign. And then this will be our final answer. In example 2, we have 14 hectometers, and we are trying to convert to meters. We're going to put HM on the bottom so that it cancels, M on the top since that's what we're looking for. Out of these two, hecto is larger, so that gets the 1, and the conversion factor for hecto goes in the empty spot, so 10 to the second. From here, we're going to multiply across, so we have 14 times 10 to the second power, and then we need to slide that decimal 1 spot to the left. If this gets smaller, my exponent gets bigger, so it becomes to the third power. So you're going to see that we're starting to add together a lot of the smaller skills that we had learned earlier in this unit. Now we're going to be going through checkpoint examples for our one-step conversions. Again, it is very important that you write out all of these examples. All right, in our first example, we have 8.5. We're starting with nanograms, and we are trying to get to grams. Whatever unit you start with always goes down to the bottom. So we have nanograms on the bottom. Whatever you're looking for goes on top. Out of these two potential units, a gram is larger, so I put a 1 next to that. On your conversion chart, nano is 10 to the negative 9th. But I'm not allowed to put a negative sign in the conversion factor, so just 10 to the 9th. From here, since this is on the bottom of the fraction, I'm going to bring it back up top. So at this point, it's allowed to be negative. So 8.5 times 10 to the negative 9th power. The nanograms canceled out, so I'm left with just grams. So that's my final answer. For number 2, we have 2.7 megagrams. I want to cancel out megagrams to get to regular grams. So mega is going to go on the bottom, and grams is going to go on top. Mega is larger, so that gets the 1, and the conversion factor from mega is 10 to the 6th. That's going to go in the empty space right here next to grams. In this one, I'm going to multiply across, and this time I don't need to flip my coefficient or my exponent, so the exponent is going to remain positive. I'm not going to switch it. Next, number 3. We have 1.7 times 10 to the 15th meters. We're going to cancel out m on our way to tm. Tm is going to be larger, so that gets the 1. And the conversion factor from our chart is 10 to the 12th power. Since this is in the bottom, we're going to have to bring that up to the top. So we end up with 1.7 times 10 to the 15th, but then we are multiplying by 10 to the negative 12th. You should remember from our lesson on scientific notation that when we're multiplying like this, we actually add our exponents together. So to the 15th power and to the negative 12th power, that's going to come out to the third power. So 1.7 times 10 to the third. All right, in our final example, we have 0.00587 liters. We're going to cancel out on our way to milliliters. Liters is larger. The conversion factor for milli is 10 to the third. So that comes out to 0.00587 times 10 to the third. This, of course, is not proper scientific notation. I do need to slide that decimal over a few spaces. So this is going to turn into 5.87 times 10 to the 0, which is the same as just 5.87. 10 to the 0 power is equivalent to 1. So it's essentially like you're just multiplying 5.87 times 1. So that covers one-step conversions. Now let's take a look at when you would need a two-step conversion. When both of the numbers in your problem have a prefix, you should convert to the base unit or the unit without a prefix first. This results in a two-step conversion. So if I am starting with kilograms and I want to get to nanograms, I have to stop at regular grams first. So here I went from kilograms to grams, and then from grams to nanograms. In our example here, because I am multiplying scientific notation, I add the exponents. 3 plus 9, which is 12. And the 8.5 just carried through. So by keeping everything in scientific notation, you're actually able to solve this fairly easy without the use of a calculator. In our next example, we are going from 2.7 times 10 to the 15th micrometers to kilometers. So I'm going to have to stop at regular meters in the middle. So micro to meters, and then meters to kilometers. Between a meter and a micrometer, a meter was larger, so that's why there's a 1 here. Micro is 10 to the negative 6, and I ignore the sign. Between a kilometer and a meter, kilometer is bigger, so that gets to 1. Conversion factor for kilo is 10 to the third. Now both of these are on the bottom. There's a few ways you can think about doing this. The way I think of it, I would add them together, so that's 10 to the 9th power, because of multiplication, and then I would bring it up to the top, which is the same as 10 to the negative 9th over 1. And then the 15th power and the negative 9th power, I added that together to get 2.7 times 10 to the 6th. All right, so now we're going to go through some checkpoint questions for the two-step conversions. We're going to start off with 254 millimeters, and we're trying to get to kilometers. Since both of these have a prefix, I know it's going to be a two-step conversion. Millimeters is going to cancel out to the base unit. If I cover up that meter, that milli out in front, I'm left with just meters. So that's what I'm going to first, meters. And then I'm going to cancel out meters on my way to kilometers. 1 meter is equal to 10 to the third millimeters. Again, I'm ignoring the negative sign for milli. 1 kilometer is equal to 10 to the third meters. That's 254 times 10. For this part, I'm going to add these two together. So that's 10 to the 6th. And then when I bring it from the bottom to the top, 10 to the negative 6th. For the final step, I need to slide my decimal over a couple of spaces to make it 2.54 times 10 to the negative 4th power. For number 2, we're starting with 64 megagrams. If we cover up that mega, we're left with regular grams, so that's where we're going to stop first. And then we're going to cancel out grams on our way to nanograms. 1 megagram is equal to 10 to the 6th grams. 1 gram is equal to 10 to the 9th nanograms. We're ignoring the negative sign for nano. The 64 carries through, and I'm going to add those exponents. So a 6 and a 9 is going to be a 15. I need to slide that decimal one spot to the left, so that's going to change my exponent. Now I have 6.4 times 10 to the 16th power. Number 3, we have 4 kilometers, and we're eventually going to try to get to centimeters. Kilometers will cancel out to the base unit of meters. Meters will then cancel out to centimeters. Kilometers are larger, and the conversion factor is 10 to the third. Between a meter and a centimeter, meters are larger. The conversion factor of 10 to the second, I'm ignoring the negative sign. This is going to multiply across. We're going to add our exponents. They're both on the top, so I don't need to flip the sign. And that's it for number 3. I'll have to slide the decimal like I did for the others. All right, our final example, we have 520 TM, and we're going to GM. TM to M, that's our base unit, meters, and then M back out to GM. Between TM and M, TM is larger, and that's going to be 10 to the 12th power. And then here, GM is larger, so M is going to be 10 to the 9th. That's the conversion for giga. Now here you're going to notice that instead of both being on the same level like they were for the previous 3 examples, now they're on opposing levels. I have one on the top and one on the bottom. This is equivalent to division with scientific notation. So this time, since I'm dividing instead of multiplying, I'm going to subtract my exponents. So I have 520 times 10, 12 minus 9 is 3. It's always going to be the top number minus the bottom number, no matter which one is on the left or the right. From here, I need to slide my decimal 2 spots to the left to end up with 5.2 times 10 to the 5th power, gigameters. And that concludes our Unit 1 notes. So these are all the topics that we have covered, which are fair game for your assessment. Before we wrap up the video, I just wanted to go over some resources that you have access to. The majority of the practice assignments for this course are submitted through the KIA website, which gives you access to immediate feedback. Please make sure that you are taking advantage of that feedback. If you do particularly poorly on any of the practice assignments, it is your responsibility to ask questions so that you can improve. You also have access to any of the labs that we've done throughout this unit. So, for example, the Measurement and Significant Figures lab. There could be questions on the Unit 1 assessment based on that. So if there's any content from any of the labs that you either were not in class for or that you just did not understand, again, it is your responsibility to make sure that you are asking for help on that. Finally, the YouTube channel. So in addition to each of the notes videos that I personally record, I have curated from a bunch of different sources chemistry-related videos and put them into each of the unit playlists. So if you look at Unit 1, you are going to see tutorial videos from Tyler DeWitt, Melissa Maribel, Crash Course, and TED-Ed. And looking at any of those videos could help you with topics that are going to be important for this unit.